You don't have to. I was just going to use this to explain something. If you want to, you can. You kind of already have that up here. But if we were to rewrite B as like the 1 plus 1 minus, it would look like this for growth and decay. Growth is a plus, decay, subtraction. This is if we have percentage. If we don't have a percentage, if we have, so this is percent, okay, say we just have like a number. They tell us like something is doubling or tripling or it's being cut in half. That is when we do this. Okay, and B in this case could be like a half if it was cutting. If it was doubles, it would be 2. Okay, so that's the difference here. Is we're going to be working with the percentages, so we're going to be working with these. Okay, but you can have situations where things are doubling, tripling, halving, whatever it may be. Okay, so those are the differences. We're going to be working with the growth and decay, the 1 plus R, 1 minus R, but I just wanted to touch on that briefly. All right, so let's look at question number 1 on the left-hand side. Left-hand side. The population of Johnson City in 1995 was 25,000. Since then, the population has grown at an average rate of 3.2% each year. Write an equation to model the growth and find the population in 2005. So, if we want to write our equation, okay, we have our y equals. Okay, we're using the general form for growth, which is that guy there. Okay, what is our A or our initial amount? Kyle? 25,000. We started with 25,000 people. Okay, and it's growing by 3.2%, right? So that's going to be 1 plus. Now, you don't write 3.2, okay? Because 3.2 is the percentage. We need to write it as a decimal, okay? So which would be like a number out of 100. So all you do is you take that and you move the decimal place 2 to the left. So it would be 0.032. Okay, that is one step that a lot of people miss. So just be careful when you're working with the percentages. And then it'll be to the x power, which is the number of years. How many years did we go up here from 1995 to 2005? 10 years. So our exponent is 10. Okay, so I'm going to pull up my calculator. I'm going to put this in. If you don't have a TI-83 to 84, you can do it on Desmos. If you can't use Desmos on your phone on a quiz or a test, but if we have a quiz or a test over this, you will be able to use such a computer and you can look at Desmos there. All right, so it'd be 25,000. Okay, so it looks like about a little over 34,000 that population would be predicted to be. Oh man, that went away. Okay, questions on that? All right, number 2, you buy a new computer for $2,100. The value of the computer decreases by 50% annually. What's annually mean? Yearly. Right. You guys are very insane on that. That's great. Okay. Write an exponential decay. So exponential decay model is where we have the 1 minus R. Okay, and it's after 2 years. So our initial value is the 2,100. Okay, 1 minus R. How am I going to write my decimal for my percentage? 0.50, or you can just do 0.5 if you want. 1 minus 0.5. Okay, to the power of 2, because we want to know after 2 years. Okay, $525 is what it's worth. Any questions? All right. Estimate when the computer will have a value of 600. So they want to know when. Okay. We're looking for x, which is the time. So if we want to know when the value is 600, here's our equation. Okay. Where am I going to plug in 600? Why? Now, for this one, we haven't got into solving these yet. It would take a whole nother lesson to teach you how to solve this. So I'm going to show you how to do this on Desmos. Okay, you could do it on your graphing calculator as well, but I'm going to just show you on Desmos for now because it'll be quick. Okay, so I'm going to go, I put in my 2100 equals, okay, and we want to know when y is 600. Okay, so I put that in when y is 600. I look at where they cross, and they cross at an x value of 1.807. So that's 1 year, I don't know, probably be around 9 months, something like that. Okay, so what would be 80% of the year would be about 9 months? Yeah, so and that, well, the calculator is different. I can show you another time. We'll get to solving for the exponent, but for right now, I just use Desmos basically. Okay, you won't have very many questions like this one. Right now. Yeah, I would. You could just say 1.8 years. It's totally fine. Yeah. And we know that obviously it'd be close to 2 years because at 2 years it was worth 525 from the previous question. Okay. Oops. I'll show you the answers. Okay. The right hand side. Go ahead and do those on your own. Okay. Work on the right hand side quickly. I'll put the answers up here in a couple minutes. Okay. And then we'll go to the back.
Yeah, I don't know the class right now, so. Oh my gosh. Oh, that makes sense. Your knees are like full. My entire body is full. And my hands. Knees are full. I just am. Oh, you guys are so cool. Don't you know that I'm different than I don't have anybody to walk with either? He struggled with the stuff he can get through. He's like, I just want to do much. I'll translate it. What's it? It's like, things. That's a good 45 minutes. Did you fall? No. I just heard it. But the sun is on the run around. Yeah, I do. Like, the little bit handle.
right, this one I need to edit because it was 2019, not 2014. So that would be 50.
Oh. I didn't realize you put that up there.
No, I just changed it.
Oh.
30. Oh my gosh, my brain. 70 would be 35. 40. Okay, so we plug in 54 here. It's one something, yeah. 10. 105. Yep. Wait. Isn't that million?
Well, it's increasing.
Yeah, it's increasing.
Oh, because it went over.
It's
Yep.
increasing.
Yep, you're right. So that would be a billion. Okay. We agree on that? Okay.
I just said to that freaking robot. I like this new robot thing. But yeah, those. Okay, yeah, I think like intelligence
All right. Number 2. Should have gotten 5,673.14. Yes. Okay. Issues on number 2. Did you have the same equation? 1 minus 0.26. How do you do this? Yeah, so then, yep, for that last one, that would be your equation. It should be 2.3 years. Any issues there?
Probably the those. It's Friday. We just took our trip. Yeah. Now we're going to the next.
Or you'll be like, I'll cut it short today and then go for the tax period.
I'll try to get it.
I didn't do anything. I was just like, give me 5 minutes or this email. And then we just. Yeah,
All right, let's head to the back. We're gonna do this is a little bit more focused with compounding. So you guys may not be super familiar with interest and all of that, but if you are getting paid interest, you want the interest rate to be high, right? Like if you're investing money into a bank account and they're like, oh, you're going to make 4% interest, compound, 4% is not too bad, okay? But if you're buying a house, okay, and they charge you interest on your loan, you're going to be paying that. So you want a low interest rate when you're buying a house. So depending on what you're looking for, you want your interest rate to be high or low. This is a little bit more, I think, applicable to finances. Like when I was working on our mortgage and figuring out taking my husband and I's salary, adding those together and figuring out what we could afford for a mortgage payment and kind of looking at what interest rates were and all of that. This is the equation that I used. Okay? A lot of times there's calculators out there now. There's people to do it for you. I try to be one of DIY, do everything, save money. So I try to do it myself because I'm a math person. But your Y is still your final amount. Your A is still your initial amount. R is still your interest rate. Okay? The only thing that we have now is we have this variable N. Okay? N is the number of compounds that you do. So for example, if we say compounded monthly, compounded weekly, compounded quarterly, that kind of thing, that means if they're gonna run it or they're gonna compound the interest that many times in a year. Okay, so when you look at your exponent, it's no longer x, it's n times t. T is time, so t kind of replaced x in a way. But the n value will be here, and it will be in that exponent. Before we do the questions, okay, you might want to write these down, okay, maybe on the right-hand side or something. If it says that it's going to be compounded annually or yearly, how many times would that be in 1 year? It would be once, okay? It's compounded once per year. What do you think semi-annually would be? Twice a year, okay? Monthly, 12. There's 12 months in a year. Quarterly, 4. Okay, I just think 4 quarters. Okay, 4 quarters of a dollar. Or a year is broken up into quarters. That's just 4. Okay, so those are going to be our n values depending on what we're asked in the question. We okay on those? All right, number 1, you would like to deposit $1,600 in the bank, and you have 3 banks that you can choose from. Obviously, you want to choose the one that's going to give you the best interest rate combined with the compounds. So, Bank A pays 2.5% annual interest compounded monthly. Okay, so when we fill this in, okay, our $1,600 is our initial value. Write our equation there, okay? And then 1 plus, how am I going to write my percent? 0.025. Don't forget to move that decimal place. What's my n value if it's compounded monthly? 12. Okay, so my n is 12. So for my exponent, I'll have 12 times t, which is my number of years. Okay, how many years are we dealing with here? 3 years. Okay, so you'll notice. Take a look at what I put in. I know it's kind of hard to see my screen here. Let me see if I can make that bigger. Nope. Whatever. I can't make it bigger. But, okay, I put everything in parentheses. So you'll notice right here, this fraction, when I put it in my calculator, I put it in parentheses. Same thing for my exponent. Okay? So if you don't put that in properly, you may get a different answer. Okay. Oh, and obviously I did something wrong.
You put 16 instead of 69.
Thank you. Like I said, if you put something in wrong. Nope, not what I wanted. All right, there we go. Yep, $17.24 and almost 50 cents. Okay, but not bad. If you think about it, right? If you just put that $1,600 in a bank account, in 3 years you've made $124.48 just by putting it in a bank account. Okay, not bad. Not bad. Let's check bank B. All right, this is compounded quarterly. What's my n value? 4. And I'm getting 1686.05. Everybody doing okay getting that answer? Yeah?
there's the 4.3, 12.3. But
Oh,
That's
it's
because it-
times 12 times 3 because you're
Oh,
doing
okay.
n. You're doing n times t, n times t.
okay, yeah. Makes sense.
All right, and then bank C, we have 4%. That's pretty steep. 4% is pretty steep. And compounded yearly. What's my n value? 1. So we'll have 1 times 3. All right, and that one's 1799.78. Bless you. Okay, obviously, which bank would you choose? Bank C. Okay, 4%, it doesn't matter how it's compounded, 4% is pretty good. Pretty good. Okay, questions on those? $1,200 is deposited in an account that pays 6% annual interest, compounded semi-annually. Find the balance after 5 years. Okay, so this is just like what we were just doing, but now we have semi-annual. So you'd have 1,200, 1 plus 0.06 over, what's my n value for semi-annual? 2. Okay, that almost means every 6 months. Not almost means, it does mean. Okay, after 5 years, you would do 5 times 2, which is your years and your n value. I'm getting 1612.7. Okay, when you're done with those, go ahead and do the right-hand side. up there for those.
I don't understand. You said it number one.
Say that again.
You said number one. That's
So it would be 2,500.
yeah.
And you would do 1 plus.
2,500. 1 plus. And is it?
0.0225
Okay, that's what it is.
over 12.
Oh, okay. I was just paying attention to this, and like I wasn't paying attention to that. That's why. Yeah.
So then, and then your power would be 12 times. Okay, any issues on these? You need to see the setup of the equation. Do you want me to write those in?
Why is it? Because it's monthly.
Monthly. Yeah, it's 12 months a year.
Yeah.
Yep.
Over here for
What?
monthly.
Not getting those?
The first one I got 42.64.
All right, let me put up the equation. That should be your equation. What's that?
I didn't get the answer.
So what's happening is we just put that, put your power in parentheses. I think what you're doing is you're doing it to the 12 power and then multiplying everything by 2. Okay. See, you started 2 parentheses here. So, let's put that in. Another parentheses in there.
Maybe close to it.
Yeah.
And we all have 6 grades.
Okay, any issues, anything I need to explain? I can come look at your calculator if you're not really sure what's going on.
Is the gym gonna be like open for lunch today? Because everybody has to stay period lunch today.
No, not every, it's just a environmental club.
Oh, that's it. They made that sound.
Well, it's because you can't hear the announcements, but it says environmental club, everybody will be. And I'm like, why did they phrase it that way? It should have been, if you were in the environmental club,
If you are in the environmental club, you will have 6 period lunch.
no, if you are, yes, everybody is eating their normal club. The clubs are completely normal except for the environmental group, whatever that club is. If you're in that club, let me know. Is anybody in that club? No, they're not. Okay. Eat your normal time. Everything's normal. Tell all your friends text right now. Okay, because we do not get everybody eating lunch. Okay, let's do the last one here. Number 4. How much must you deposit in an account? What are they asking you for when they say how much must you deposit? They're asking you to find A. Okay, and it pays 6.5% to have a balance of 5,000. Okay, so 5,000 is your Y. So if we set this up, okay, we haven't done one of these yet, so make sure you're paying attention here. 2 times 15. Okay, so I would set that up like normal, but I don't have my A value. Okay, I don't have A, I need to find A. A is being multiplied to this set of parentheses. Agreed?
Yeah.
Okay. I literally have gotten rid of all of them. So, to get rid of the parentheses, we can just divide by it. On both sides. Okay, so it will cancel out over here. We'll have A left by itself. then from here, in your calculator, you'll just put that whole thing in there. Okay, so you're basically just dividing something out and solving for a variable. You should get 1915.44. Okay, we're going to work more on these on Monday. We'll do a math lib on Monday. That'll be kind of fun. So, it's about 5 minutes left. I did not. It's just a lot of writing.